Good day, everyone. I am Glenda Postrado, together with Vanessa Mateo, Carla Joyce Puno, and Ella Jean Timbang, the Group 4 in BS Ed Mod 3A assigned to answer exercises 7.1, items 1, 9, 17, and 25. Glenda Postrado assigned in number 1. What is the difference between a point estimate and an interval estimate of a parameter? Which is better and why? So first, let us define some terms. Parameter. What is a parameter? Parameters are numbers that summarize data for an entire population. Example, we want to know the average length of a butterfly. This is a parameter because it states something about the entire population of butterflies. Then estimation. It is a process of estimating the value of a parameter from information obtained from a sample. Examples: 1 out of 4 Americans is currently dieting. The average kindergarten student has seen more than 5,000 hours of television. So these two are examples of estimate. What is a point estimate? A point estimate is a specific numerical value estimate of a parameter. The best point estimate of a population mean is the sample mean. Example: suppose a college president wishes to estimate the average age of students attending classes this semester. The president could select a random sample of 100 students and find the average age of these students, say 22.3 years. From the sample mean, the president could infer that the average age of all the students is 22.3 years. And what is interval estimate? An interval estimate of a parameter is an interval or a range of values used to estimate the parameter. This estimate may or may not contain the value of the parameter being estimated. Example, you might think that the mean of a data set falls somewhere between 10 and 100. So what's the difference between a point estimate and an interval estimate of a parameter? A point estimate is a single value estimate of a parameter, while an interval estimate gives you a range of values where the parameter is expected to lie. Which is better and why? The answer is interval estimate, because in here, you provide a range of values with a known probability of capturing the population parameter. It helps one to not be so confident that the population value is exactly equal to the single point estimate. That is, it makes us more careful in how we interpret our data and helps keep us in proper perspective. And although a point estimate is the single best guess you can make about the value of a population parameter, it is also usually wrong. Interval estimate overcomes this problem using interval estimation technique, which is based on point estimate and margin of error. That's all. Thank you.
I am Carla J. Spuno and I will show you how I answered number 9, exercises 7.1. Our given, find each. We have A, B, C, D, and E. We need to find Z sub alpha divided by 2 for the 99% confidence interval, for the 98% confidence interval, for the 95%, for the 90%, and for the 94%. The symbol Z sub alpha divided by 2 is used in the general formula for confidence intervals. The Greek letter A, alpha, represents the total area in both tails of the standard normal distribution curve, and alpha divided by 2 represents the area in each one of the tails. Letter A, Z sub alpha divided by 2 for the 99% confidence interval. we have alpha, or the alpha level, the whole area or percentage, minus the given percentage. And it must be in the decimal form. And next, alpha divided by 2, we divide the alpha level by 2. And z sub alpha divided by 2 is the critical value for the z distribution table that corresponds to alpha divided by 2. First, we need to find the z sub alpha divided by 2 for the 99% confidence interval. We have alpha equals 100% minus 99%, which is the given, and we subtract. Now we have 1%, and we divide it by 100. Now we have alpha equals 0.01, and we divide it by 2. Now we have 0.005. This is our alpha divided by 2. And now we look for the closest value on the z table. We are looking for the closest value of 0.005 on our z table. We have two closest value for our 0.005. 0.005 was not exactly on the table. Therefore, the closest values are 2. We have 0.0051 and 0.0049, and their corresponding values are negative 2.57 and negative 2.58. We go back on our problem, and based on our table, the closest values for 0.005 are 2. We have 0.0051 and 0.0049. And their corresponding values are negative 2.57 and negative 2.58. We subtract our value 0.005 to the closest values that we got, so we can determine their gap. We have 0.0051 minus 0.0050 equals 0.0001. And next, 0.0050 minus 0.0049 equals 0.0001. As we can see, they are same in gap, or the distance from our value. Therefore, we use both corresponding values to solve for z sub alpha divided by 2. We are going to add the corresponding values and then we divide by 2. We have negative 2.57 plus negative 2.58 divided by 2 equals negative 5.15 divided by 2. Now we have negative 2.575 and equals negative 2.58. We have two decimal places. And therefore, the critical value of z alpha divided by 2 that corresponds to the level of 99% confidence level is 2.58. Our answer will be positive. Next, we have letter B. Z sub alpha divided by 2 for the 98% confidence interval. First, we are going to look for value of our alpha. 100% minus 98% equals 2%. And then we divide 2 by 100, so we get its decimal form. Now we have alpha equals 0.02. And next, we are going to divide it again by 2. Now we have alpha divided by 2 equals 0.01. And next, we are going to look for the closest value on the z table for our 0.01. Remember, we are looking for the closest value of 0.01. We have 2. 0.01 was not exactly on the table, but its closest values are 2. We have 0.0102 and 0.0099, and their corresponding values are negative 2.32, and negative 2.33. We go back on our problem. Based on our table, the value or our value 0.01 has two closest values. We have 0.0102 and 0.0099. And their corresponding values are negative 2.23 and negative 2.33. We subtract our value 0.01 to the closest values that we got so we can determine their gap. We have 0.0102 minus 0.01 equals 0.0002. Next, 0.01 minus 0.0099 equals 0.0001. As we can see, the 0.0099 is closest from our value. Therefore, we are going to use corresponding value of 0.0099 for z sub alpha divided by 2. We have negative 2.33. Therefore, the critical value z sub alpha divided by 2 that corresponds to a level of 98% confidence in level is 2.33. Again, our answer will be positive. Next, we have letter C. Z sub alpha divided by 2 for the 95% confidence interval. We have alpha equals 100 minus our given percentage, which is 95%. Therefore, we have 5%. And then, we divide by 100 to get its decimal form. We have alpha equals 0.05. And again, we're going to divide it by 2. For our alpha divided by 2, we have 0.025. And now we are going to look for the closest value on the z table for our 0.025. Remember, we are looking for our value, the closest value for 0.025. 0.025 is exactly on the table, and the corresponding value is negative 1.96. Back on our problem, and based on our table, the 0.025 is exactly on the table, and the corresponding value is negative 1.96. Therefore, we use the corresponding value of 0.025 for our z sub alpha divided by 2. Therefore, we have negative 1.96. And our answer will be the critical value z sub alpha divided by 2 that corresponds to a level of 95% confidence level is 1.96. Next, we have letter D, z sub alpha divided by 2 for the 90% confidence interval. Again, alpha, we have 100% minus our given percentage, 90% equals 10%. And then we divide by 100 to get its decimal form. Now we have alpha equals 0.1. And we divide it again by 2. Therefore, we have alpha divided by 2 equals 0.05. And for our 0.05, we are going to look for its closest value on the z table. Remember, we are looking for the closest value of 0.05. Our value 0.05 was not exactly on the table. The closest values are 2. We have 0.0505 and 0.0495. And their corresponding values are negative 1.64 and negative 1.65. Back on our problem, based on the table, the value 0.05 has two closest values. We have 0.0505 and 0.0495, and their corresponding values are negative 1.64 and negative 1.65. We subtract our value 0.05 to the closest values that we got, so we can determine their gap. we have 0.0505 minus 0.05 equals 0.0005. And next, 0.05 minus 0.0495 equals 0.0005. As we can see, they are same. They are same in distance from our value. Therefore, we use both corresponding values to solve for z sub alpha divided by 2. We are going to add the two corresponding values. We have negative 1.64 plus negative 1.65 over 2. We have negative 3.29 over 2. Then we divide. We have negative 1.645, and then two decimal places, we have negative 1.65. Therefore, the critical value z sub alpha divided by 2 that corresponds to a level of 90% confidence interval is 1.65. And lastly, we have letter E. Z sub alpha divided by 2 for the 94% confidence interval. We solve for our alpha, we have 100% minus the given percentage, which is the 94%. We have 100 minus 94% equals 6%. Then we divide it by 100 to get its decimal form. We have alpha equals 0.06. And we divide it again by 2. So we get the alpha divided by 2 equals 0.03. And we look for the closest value of 0.03 on the Z table. Remember, we are looking for the closest value of 0.03. 0.03 was not exactly on the table, but the closest value is 0.0301 and the corresponding value is negative 1.88. Back on our problem, we have 0.03 and based on our table, the closest value is 0.0301 and its corresponding value is negative 1.88. Therefore, we use the corresponding value of 0.0301 to solve for z sub alpha divided by 2. Therefore, we have negative 1.88. Our answer will be the critical value z sub alpha divided by 2 that corresponds to a level of 94% confidence level is 1.88. These are our final answers. We have the confidence interval and our z sub alpha divided by 2. For 99%, we have the 2.58. For the 98%, we have 2.33. For the 95%, we have 1.96. For the 90%, we have 1.65. And for the 94%, we have 1.88 z sub alpha divided by 2. Thank you for listening.
Good day everyone, my name is Ella Jane H. Timbang from BSED Math 3A and I'm assigned to do the exercises 7.1 item number 17. For item number 17, we have a study of 415 kindergarten students showed that they have seen on average 5,000 hours of television. If the sample standard deviation of the population is 900, find the 95% confidence level of the mean for all students. If a parent claimed that his children watch 4,000 hours, would the claim be believable? So for item number 17, here's our given. Let n is equal to 415 be the sample size. Then the sample mean or the x bar is equal to 5,000 hours. And the sample standard deviation, b the sigma is equal to 900 hours. Since we have to construct a 95% confidence interval, the corresponding value of z sub alpha over 2 is equal to 1.96. The sample size is big enough and the standard deviation is already given. So the formula for calculating the confidence interval of the true mean is in between of sample mean minus the c sub alpha over 2 multiplied by sigma over square root of n and sample mean plus C sub alpha over 2 multiplied by sigma over square root of n. By substituting the known values into these inequalities, we obtain the wanted interval. So here's our given. N is equal to 415, sample mean is equal to 5,000 Rs, and standard deviation is equal to 900 Rs, and Z sub alpha over 2 is equal to 1.96. We just have to substitute those given into the formula wherein mean is in between of sample mean minus Z sub alpha over 2 multiplied by sigma over square root of n, and sample mean plus Z sub alpha over 2 multiplied by sigma over square root of n. So let's now substitute. So sample mean is 5,000 and Z sub alpha over 2 is equal to 1.96, and our standard deviation is equal to 900 Rs, and our n is equal to 415. So mean is in between of 5,000 minus 1.96 multiplied by 900 over square root of 415, and 5,000 plus 1.96 multiplied by 900 over square root of 415. So 900 over square root of 415 is equal to 44.17926. So mean is in between of 5,000 minus 1.96 multiplied by 44.17926, and 5,000 plus 1.96 multiplied by 44.17926. And for 44.17926 multiplied by negative 1.96 is equal to negative 86.59134. So we have mean is in between of 5,000 minus 86.59134 and 5,000 plus 86.59134. So we have mean is in between of 4,913.409 and 5,086.591 Rs. So for item number 17, if parent said his child watched the television for 4,000 hours, it wouldn't be believable, since according to this 95% confidence interval, an average is estimated to be between approximately 4,913.41 and 5,086.60 hours. And that would be all. Thank you.
Hi, I am Vanessa B. Mateo, BSED Math 3A, assigned to answer item number 25 of chapter 7.1. The given problem is, if the variance of a national accounting examination is 900, how large a sample is needed to estimate the true mean score within 5 points with 99% confidence? From this problem, the given are, we have the maximum error of the estimate, which is equal to 5, a variance of 900, and the 99% confidence interval. What is asked in this problem is the sample size needed to estimate the true mean score within 5 points with 99% confidence. To solve that, we have to use this formula for sample size, where n is equal to the square of the quantity of the product of C sub alpha over 2 and the standard deviation all over the maximum error of the estimate, or E. Now, we have learned from this chapter that for a 99% confidence interval, C sub alpha over 2 is equal to 2.58. Then, given that the variance is 900, therefore the standard deviation is equal to 30 by taking the square root of the variance, which is 900. Lastly, the E, or the maximum error of the estimate, is equal to 5 as given. Now, by plugging in these values to the formula for sample size, let us find n. So, our n would be equal to the square of the quantity of the product of 2.58 and 30 all over 5, and with the use of our calculator, n is equal to 239.6304. But the rule is to always round up n to the nearest whole number. So our n here should be equal to 240. Therefore, to be 99% confident that the estimate is within 5 points of the true mean score, the sample size needed is at least 240. That is all. Thank you.